with Jarlath O'Neil-Dunne of the UVM Spatial Analysis Lab and Jon Budreski of Airshark. I'll be handing things over to Jon and Jarlath in just a moment. I just want to do a quick, everybody on the same page exercise, just so that we're all familiar with the GoToWebinar interface, and also I'll give you a quick demonstration of where we post our recording after the webinar. So I don't have my slide that I usually do to point at to have everyone know what they should be clicking on in their GoToWebinar panel. But I just want to point out that the little orange button that's an orange rectangle with an arrow in it is what you will use to collapse and uncollapse your panel. So if you find that the panel is in your way on your screen, you just click that little orange button and it'll collapse down. If you want to open it back up so you can type in a question, you just click on that same little button. If anyone's having issues with the audio, you're probably not going to hear my instructions, so it's probably no point in mentioning this, but you do just need to open up your audio section of your panel and make sure your settings are set correctly. The only other thing I want to point out is that if you find the little orange hand button that's on your panel and go ahead and click on that little hand, that lets me know that you can all hear me. And if everybody could go ahead and do that now, that would be great. Thank you. That's sort of the raising your hand button. Great, thank you. Oh, and actually the other two things are that we are recording the webinar, so it will be recorded and posted later. And also, when you have questions, there's a section of your panel that you can open up and type in a question. You're all muted right now, but you can type in your question. It will get sent to all three of us actually, and Jon and Jarlath will be kind of keeping an eye on the questions to see if any of them need to be answered right away, and any that can wait will be held towards the end, and then they'll take some time to answer those questions. So let me just quickly show you that on the front page of our website, there's a link to our YouTube page, and that's the quickest way to get to the recorded webinars. You'll see that we've got a bunch of other webinars already posted here. So within a few days, probably by Friday, I will get this posted up on our YouTube page. The other thing I want to point out is that we have an event archive page. So if you click on events in the navigation bar and then event archive, and then webinars, it takes you to the section where I post basically just links to that YouTube page. But in some cases, I do also post the PowerPoints that presenters give me, and Jon will be sending me the PowerPoint afterwards. And so I will post that here. So if anyone's interested in just having access to the PowerPoint itself. Okay, I am going to hand things over to Jon now. And I'll ask Jon and Jarlath to kind of introduce themselves a little more fully as they choose. Okay. It's all yours, Jon.
Thanks, Leslie, and welcome everybody. As quite a few folks have signed up today. If there's any audio issues, like you said, just feel free to chime in on the dashboard. My name is Jon Budreski. I'm here with Jarlath O'Neil-Dunne from the University of Vermont, and Jarlath works in the Spatial Analysis Lab, and I'm with Airshark. We at Airshark are a drone services company focusing on commercial industrial inspection and doing some more mapping day-to-day as well, as there's quite a few projects that require both aerial imagery and 3D, 2D mapping as well. Jarlath heads up the Spatial Analysis Laboratory at UVM and has a team also doing similar work, although a lot of wide area mapping as well, where we're going in and looking at closer inspections. Typically, we're seeing ourselves overlapping more and more. And Jarlath, I don't know if you have anything to add.
Yeah, thanks, Jon. Well, it's great to be here with all of you, and always great to be with you, Jon. I think Jon and I both sort of share a passion for this technology and really the proper use of its technology. Here at UVM, like Jon mentioned, we've been primarily focused on sort of, I'd say, more the GIS-y type applications of UAS, so we're talking about slightly broad area mapping. And I think with both of us, you get some overlap, but really some unique perspectives, everything from the close-in inspection side to some of the broader area mapping applications of UAS.
Thanks. So today we have quite a few slides. We'll try to move quickly and have enough time at the end to do some Q&A, but feel free to pipe in as we go if there's anything imperative that's on your mind. But two of the primary objectives are, deciding, are unmanned systems right for your project? Are they the right tools? When, and if so, how and why? And how do you contract out for UAS services? Because right now there's a limited number of providers that can operate in the national airspace under the guidelines of the FAA and state aviation. So we'll get into the ins and outs of some of those details and try not to bore you too much with the regulatory side of things, but it's actually pretty interesting, and there's a reason for everything, even though it's frustrating for some companies that just want to get out there and explore with their own unmanned systems today. There's some safety constraints and other items that we'll talk about. So the question is, why unmanned systems? Why are we seeing such a plethora of multi-copters and wings out there used in different agencies, from the federal and state government to private contractors? And a lot of it has to do with the advent of the smartphones a decade ago, and micro sensors, better cameras, better batteries, and the need for tons of quality information spatially and temporally. So it's a perfect storm right now, and that's why we're seeing such a confluence of this technology. Some of the applications today allow for much greater temporal resolution, looking at nadir straight down on a traffic intersection, for instance, before and after projects. We can really get details that previously were just prohibitively expensive or difficult to access. In this case, state transportation and/or private contractors working on a project will look for details and share this data with different stakeholders before and after. So having this information shared amongst a team is very valuable. And in this case, we're looking at obviously a rotary with some new line paint and sidewalks, and basically before and after photos that are very helpful in a tremendous amount of ways here. So the temporal resolution is one why. The resolution of images from 200 to 400 feet above ground level with relatively modest sensors is also powerful. So, counting debris in streams or boulders, or looking at the health of culverts and roadways is another important element that, in this case, is beneficial to several different stakeholders. This is a project. Jarlath, if you want to step in and talk about the before and after here, this is an interesting one.
Yeah, thanks, John. So we did a project in partnership with the town of Plainfield monitoring the Great Brook, and they had a lot of issues there with woody debris flowing down and damaging their bridge, and this is something that you just couldn't have done any other way. It's too dangerous and expensive to do the field surveys. Manned aircraft would have broken the bank, and you just wouldn't have been able to see the things you wanted to see with satellite imagery. So monitoring the brook, we were able to do this for months leading up to one of their major storms that they had in July, and get before and after imagery not only of their damaged infrastructure, which is useful if you're applying for state or federal reimbursement, but also to figure out the amount of woody debris that was in that stream and what was happening to it during these major storm events.
Looking at an energy asset like a solar farm, which is a modestly sized solar farm, probably 0.5 megawatt or so, sort of amplifies the fact that it's safer to use a small, lightweight unmanned system when we have high voltage that's fenced in, and very few entities that are allowed access to check on this system, whether it's a wind turbine or a solar farm, for instance, in this case, using a small unmanned system to check for storm damage, vandalism, or the health of the solar cells is something Airshark does quite a bit of, and we've gotten more involved in mapping these sites for before and after planning as well. So it's an interesting segue that I've transitioned into from previously installing some of these projects. But it's also pretty cost effective, as Jarlath was saying, to in relatively short order get up there, collect the imagery, and come back down in under 10 or 15 minutes. So it doesn't cost an arm and a leg to collect that data for a 5 to 10 acre site. So before we get too far into the details of the regulatory environment, a few slides on types of unmanned aerial systems today. And some of us have seen the white phantoms in the lower left. We've got multi-rotors, multi-copters that can carry sometimes larger sensors and cameras and have advantages for taking off vertically in more dense areas where there's constrained vegetation or trees around. And then we're seeing more lightweight foam-based wings that basically have a pusher prop to the rear of the aircraft, a onboard processor the size of a smartphone with a small camera and a GPS. So the ground station and the drone communicate with telemetry and radio frequencies during these flights. And that whole interface is the unmanned aerial system. So it's more than just the actual drone. Is quite a bit that goes into effectively having a mission. But this is just a quick snapshot of some of the unmanned systems out there today. The multi-copters are typically launched in a flat area. They can be autonomously programmed. The wings are launched by hand typically. So you need an open area to launch and to land the wings. So there's some strengths and benefits of each of those platforms. And at the end of the day, any of those platforms can collect the data. So it just depends on what's available and what the mission is. You might be able to fly longer with the wings, for instance, but you can get up closer to a bridge with a multi-copter. So why not just go to Amazon and pick up a drone for a few $100s today and zip around? There's plenty of people that are doing that, and from a regulatory standpoint, it is legal to zip around it from a consumer hobbyist standpoint, but from the commercial standpoint, there's some pretty strong considerations to understand from the FAA, and there's a clear protocol for operating commercially in the national airspace. When I say the national airspace, I'm talking about anything from the ground level up to 60,000 feet of altitude. And we're specifically talking about light or small unmanned systems, so anything from half a pound up to 55 pounds. So the FAA mandates and creates the airspace and wants to maintain a safe, obviously, airspace for not only folks on the ground, but aircraft in the air that have been operating successfully for almost 100 years. So tagging on to that, today there's obviously a simple registration process for recreational use of small multi-copters and fixed wings. But on the commercial level, the Section 333 is a way to operate and become approved as a commercial entity. It's similar to obtaining a CDL. I guess I'd look at it like that, to drive a large truck on the highway, where the operator has some standards and training necessary to operate certain equipment on the roadway, which also undergoes regular maintenance and safety checks from the Highway Administration or other entities. So in many ways, it's that peace of mind for other people using, the airspace. And in the case of a CDL, it's the highway.
So John, just to jump in here, we had a question about, is it considered commercial use if a private business owner uses one to acquire aerials of his or her own business? And my understanding from talking to the FAA is yes, that is a commercial use, and you do need a Section 333 if you want to add anything to that.
No, that's correct, and hobbyist recreational use is outside of that, that's going to the field on a Saturday morning or something and zipping around. But the FAA is actively investigating the use of UAS potentially commercially from unauthorized people, so that there's a reason for rules. So get into the equipment in terms of why not do it yourself. I mean, the hardware is changing just so rapidly between the sensors, the motors, the batteries. It's hard to keep up with. I mean, we just try to focus on one or two platforms, and that alone is difficult. So it becomes expensive to manage a fleet, and you need to have a fleet of these systems and redundancy to really make it work. So hardware is a component. But really the data processing is another element where service providers should have training and sometimes licenses to utilize the analytics packages that sometimes come with the unmanned systems or sometimes are implemented into the workflows. So it's incredibly time-consuming to learn and purchase and get on training for these data packages. And obviously, this is pretty self-explanatory. And we see this more and more in the news, and I'm sure it's only a matter of time before bad things happen. And I think last week there was someone that went out onto a lake and fell in the water. I'm not sure if he drowned or not, but he was trying to find his missing drone. And it's unfortunate. We're seeing just human behavior sometimes not at its very best. So. We try to use our experience and say no to a lot of projects if there's a dangerous situation. So in terms of the data capture and what sort of data today that we're looking at, really four main elements. I mean, the geotagged imagery and obliques, whether it's video or stills, are incredibly useful. Especially at low altitudes to inspect close-in structures or geographic elements of the landscape. We've got ortho photos, point clouds, which are tremendously powerful, and surface models, whether it's DSM or DTMs. Sometimes on the same flight, we can capture all four elements for our clients, and then different stakeholders may use a component of certain data, which before they just didn't have access to or didn't know about. So there's some real benefits there for the four elements coming together. Whereas in traditional surveying from aerial photography, you may only have one or two of those data types present or allowed, and now we're getting all four. So next slide. Just going to talk briefly about some of the capabilities and limitations relative to weather, terrain, etc. And going from left to right here, we're looking at what's available today for sensors versus what's available in the future. And electro-optical or visible cameras collect, obviously, still and video. We've got smaller multispectral and thermal infrared cameras to collect data for, say, energy applications or forest canopy health. And we're starting to see LiDAR into the mix here, although it's still kind of clunky, expensive, and the resolution isn't quite what we need in the industry for unmanned systems, although that is changing. Within a year or two, we'll probably see more lightweight LiDAR units out there. And even things like gas sensors are being developed to map out leaks of industrial sites that either generate or transport gas. So that's something that's exciting as well. But going back to the capabilities, if it's a nasty day out there, it's windy and cold, we can generally operate. A good service provider should be able to operate year-round. When it gets to be about 20 miles per hour of winds at the surface, that starts to get a little tricky. And basically the cutoff is the same as a light aircraft. When you have a 20 or 25 mile an hour wind, it's just too difficult to take off and land, whether it's a vertical takeoff or a wing. Even precipitation obviously is not great for electronics, so if it's heavy or moderate, that's just a no-go. In terms of mapping area, again, the limitation is often the batteries. So most UAS can fly for under 30 minutes at this point. The solution there is to have more flights. If it's a site that's several hundred acres, you just may have to have 5 or 10 flights to cover that area, which is not a big deal. It's usually a turnaround of a few minutes on the ground to insert another battery. In terms of terrain and obstacles, obviously having an awareness in terms of mission planning of, are there structures, are there bridges or power lines nearby? Is the terrain forested? Being able to see the ground in an open area obviously helps with photogrammetry and stitching images. Without using LiDAR or using photogrammetry, we really need to be able to see the ground to get decent elevation data, or X, Y, and Z for that matter. But we've worked in several areas at Airshark with severe terrain and had very few problems with cliffy areas as well, so it can be done. In terms of temperature, it's what can the operator handle. I don't like to hang outside if it's below 0 or over 100, but the actual unmanned systems can take a beating in terms of temperature and environmental, so they can work. And cold weather does not slow them down at all, because these batteries tend to heat up when they're working. Some of the basic constraints today for operational purposes, if you have projects you're thinking of, is line of sight, having a line of sight on the unmanned system. So the pilot and the visual observer need to be able to see it, and that could be a couple thousand feet in some cases, which is pretty far. But if there's rolling hills and trees around, you may not get more than a couple hundred feet until you have to move to another spot. So that's a limitation, and the reason for that is safety. If you have to duck out of the way of an angry bird or a power line or a medical helicopter, it's the pilot's responsibility to see and avoid other objects in the sky at this point. Most of these aircraft are not carrying transponders, so that's the reason for the line of sight operation. In terms of airspace, generally speaking, staying outside of 5 miles from operating airports with control towers or instrument approaches. Many airports have an instrument approach procedure that allows low-flying aircraft to come in, so that's the reason unmanned aircraft are not allowed to fly near them. Generally, 400 feet or less AGL or above ground level is the altitude constraint. Now there are ways around it, but it's fairly boilerplate at this point, the operational constraints. So I'm just going to talk about the contract requirements and sort of what questions to ask. And again, the FAA 333 exemption allows for commercial operators to enter the airspace and operate, and it's a fairly arduous process. So in addition to the FAA approvals and additions necessary there's insurance and safety elements to be aware of. Experience obviously is something you want to ask the operator about. What types of aircraft have they flown, and have they done that particular application? It may be okay if they haven't, but you may have to do a little more hand-holding and learning to work with the operator in that case. And then for processing, really it's all about the data types, asking what the operator is going to have for a deliverable at the end of the day. And we'll get into that in a few more minutes as well. But as you can see, there's quite a few elements that come together for a successful operation. So knowing sort of what questions to ask is important, but I'll try to have this as a PDF after the presentation to give folks an idea of what questions to ask. So I'm going to let Jarlath take it away here in a second, if I can.
Great, thanks, John. And we also have some questions that I think now is probably a good time to pause and answer. One of them was about, do either of us have a 333 exemption that allows beyond line of sight? So no 333 exemption will give you line of sight or beyond line of sight authorization. What this means is that you cannot see the UAS while it's in the air. You can file for a COA, these certificates of authorization that might allow you to do that. To my knowledge, they're only happening at the UAS FAA test sites. I think, John, you and I have talked about this, and it may be worth at some point in time going for one of these beyond line of sight operations in Vermont, because we've sort of got ideal terrain here, not a lot of people out there, not near an FAA controlled airport. So that would work well, but they are not being widely issued, but the systems will do them. Another question was no radar, and I think this really gets down to the fact that anything you're going to put on those UAS, whether it's a light or a radio, is going to eat up the power source, which means you need a larger power source, which means you need a larger UAS, and it doesn't take much before your UAS is suddenly big enough that you need an airport to launch it from, or at least some sort of small runway. And then I think, especially when we're talking about Vermont, it's really defeating the advantages of your UAS. The next question we've got here, is a pilot's license required for UAS operation under a 333 exemption? Question the answer there is really the same. Yeah, if you're using it for anything other than recreational purposes, you need to have a pilot there available to you. Let's see, software, I think we'll tackle that because I'm going to get to that. And the other one was scientific research be considered commercial. Yes, anything that is not recreational means you are strictly a hobbyist going out there doing it on your own time. You fall into either the public, the civil, or commercial categories, and you either have to have an FAA Section 333 or certificate of authorization, so you're sort of FAA quote-unquote certified. You need a pilot and have to obey by all those rules. It is a little bit confusing on the FAA website because they don't have a separate like educational or you're a nonprofit organization, but those all fall under either the civil or commercial regulations. Did you want to add anything to that, John?
No, I think you hit the nail on the head. That's perfect.
Great, thanks. So let's get into the contracting aspects, and really what I hope to do here is assist you with moving forward with paying someone to collect UAS data for you and the things you want to think about. So starting up in the upper left there, think about your area of interest. Okay, you want to make sure that it's achievable. The systems that we're talking about are small and lightweight. These are not the military drones with billion-dollar communication systems behind them. Really think of sites that are on the order of a few hundred acres, you know, maybe 1,000 or so acres. You might get a little bit over that during a given day, but you're not going to be mapping your entire town. You're not going to be mapping the transmission lines for the state of Vermont using UAS. So think of these small area systems, you know, mapping a few hundred acres, getting great ortho photos, or with Airshark, they're doing really detailed inspections of sites. You want to make sure you've got permission for the land you're launching and flying from. You want to make sure you've got a good launch site. If John's flying his hexacopter, he can easily take off and land in a small area. If we're using our fixed wing systems, which get us a little more coverage, we're going to need some sort of open field. So the accuracy specs, and we'll go into some examples here in a little bit, you want to think about what your horizontal accuracy, what your vertical accuracy need to be, and your resolution. And you want to think about ways you can verify that, specifically on the horizontal and vertical accuracy side. So you might want to have a surveyor out there, and you might want to think about putting out targets during the flight that either are going to be used as ground control points to reference your data or as independent verification points to see how accurate your data are. John talked about some of the issues with weather, and so with your collection specs in that contract, you really want to think about what time of season, time of day, things like lighting can really influence the quality of your data at times, particularly if you're looking to derive some sort of surface model from photogrammetric methods. And you might want to have a weather clause in there, right? How many times is the person going to go out, and if it's windy every time, how are you being compensated, or how is the vendor being compensated for that? When you get sort of to the delivery phase, you want to think about what products do you want. So typically you'll see things like orthophotos, you'll see photogrammetric point clouds, which I'll show you here, you'll see raster surface models, and you may want derivative things. You may want someone to filter your point cloud to try to remove the buildings and trees. You may want contours. Think about all of those. Think of the formats. Okay, you only need a couple hundred acres of UAS imagery at 3-centimeter resolution, and you're well into the many, many gigabytes of data. So do you want it compressed to JPEG 2000? What's the compression ratio? And finally, think about the ownership of that data and who's going to maintain access to those products. And finally, the cost. Don't just think about the external costs of what you're paying the vendor, but think about the internal costs. You know, your time going out there, working with them, and then also you want to make sure that you have the internal capabilities set up to manage these data sets. If you're hiring someone to go fly an area multiple times, you know, you may be into the hundreds of gigabytes worth of data, very, very high resolution large data sets. Make sure you have the systems capable of working with them. So take a look at an area of interest. Often when we're working with people, John and I, you know, sort of you can send along a shape file, you can send along a KML file that you've generated in Google Earth, but be really specific for the area that you want to fly, okay? The worst thing you do is you hire someone, they go out and fly that area because it's based on a verbal description or a written description in an email. Give them the actual polygon. When we get to accuracy, let's talk about some real-world examples here. What you see there, those little black boxes with a cross in the middle, that's a target that was placed on the ground during a UAS flight. This was very recently, so it's a field. You can see the snow on the ground, and the bare ground is about 3-centimeter resolution. That green dot is the actual surveyed location of that ground control point, okay? So over on the left, what you're seeing is a fixed-wing UAS flown, and the imagery was corrected only using the onboard GPS, all right? So the accuracy here, it's off from the true location, so that target is off from that green dot by actually over a meter there, okay? When we use those GCPs to actually correct the data, so when we orthorectify the imagery using those GCPs, you can see excellent agreement there, which is what we'd expect if we're using those as control points. Over on the right, you see a different system that we flew at the same time that uses the real-time kinetic or RTK GPS correction. So in this case, the GCPs were not used. This is the onboard RTK correction. You also see we get excellent agreement there. So now the RTK systems cost a lot more, so the vendor's going to charge you more. Setting GCPs out is going to cost you more, and you're probably going to need a surveyor out there. So keep in mind, with accuracy comes a cost, and it's probably financial. We'll look at another example here. Here we have in the middle, we have a 15-centimeter orthophoto, true color. Okay, this met the Vermont specs for orthophotos. Over on the left, we have a system flown that was only using GPS correction, and over on the right, flown at the same time, we have a system using the higher end, the GPS with the real-time kinetic or RTK corrections. So you see the improvement of accuracy that you get. So if you have a place like Chittenden County, for example, here in Vermont, where you've got very high-resolution orthophotos, you might be able to use those for quality control. But it's very important that you think ahead of time what you're going to use to assess both the accuracy and quality of your data. Okay, so in addition to orthophotos, we can generate point clouds from our UAS data. These are photogrammetric point clouds, so they're not the same as LiDAR, but in certain cases, especially when you're looking at hard surfaces, and here we have an example on the left of a point cloud profile from airborne LiDAR in the same building done from a UAS photogrammetric point cloud. These two building heights are within centimeters of each other. So these photogrammetric point clouds can be very accurate, but we'll see in other areas where you've got shadows and trees and water, the elevation accuracies can sometimes be substantial, and it's important to keep those in mind. So let's take a look at some recent projects that we've done and some issues that you should be aware of when evaluating your data. So in this case, I want to draw your attention to this little mound here, sort of to the right of center of your screen. You can see there's got some shadowing on there, and this is a project that we flew under extremely windy conditions very, very early in the morning. Okay, so really less than ideal conditions. That's the orthophoto. This is the digital surface model that was generated in preparation to building that orthophoto. Okay, so when we ortho-rectify the images, we use a terrain model that's generated from the overlapping photos to do that. And what you see here is the data loss that's occurred over that area. Okay, so accuracy is going to suffer over that area in the orthophoto because we can see that it wasn't able to match points between them due to the shadowing in the terrain, and also any elevation measurements we hope to make from our point cloud aren't going to be very good. And so one of the things you probably want to consider when you're specifying your deliverables is to get what you see here. This is the point cloud for that project. We're looking at it from a slightly different perspective, but you can see that mound over on the right there again. There's no points. No points indicates no matching between images, which means we've compromised the accuracy of our data within that specific area. Okay, small gaps are always going to occur, but if we're really interested in making detailed measurements in that area, we need to keep in mind that the data might be slightly compromised. Doesn't mean invalid or throw it away or anything like that. These are some additional deliverables that can help you understand the quality of your data. Here's an area that we did over a lake. So this here in this rectangle, I'm showing you the extent of the area that we flew. This is imagery from Google Earth. This is not UAS imagery. And the next slide here, we're looking inside our photogrammetric software and looking at where the photos failed to match to one another. Okay, so all those red ones that you see there, those are images that could not be ortho-rectified. So we've got data loss. The reason why that there's data loss out there is because we're over water, there was a little bit of wind, it cannot find matching points between those photos. So as a result, we're only getting imagery closer to shore. So your choices there are really to try to fly at a higher altitude, keeping in mind the FAA limits, and getting as much of the shoreline as possible to ensure that you have tie point matching. Okay, another project here, a lot of you saw this in the news. This is just the base imagery for the area in Northfield that Amtrak train derailed in the fall. We tried to fly this entire area. We did it in the fall. There was a little bit of wind. The trees were changing color. We only got ortho photos, so we were only able to ortho rectify the imagery for the area that you see here. Now, the imagery for the train came out excellent, so we met our project objectives, but what you see here is a lot of data loss over in that pure forested area. Okay, so meaning that because of the trees and their condition at the time, we weren't able to get good ortho photos. And if we move over to the digital surface model, which you see in this next slide, that also gives us a very good indication. You see that interpolation, those triangulated areas where we didn't have good matching between the photos. If we move into our photogrammetric software, okay, so these are things that you might want to specify in a report. We use Pix4D. Jon over at Airshark uses Agisoft, very similar workflows. We can get this output here and show you the area that we acquired and where the images failed to ortho-rectify. And then we can go ahead and take a look at that point cloud. We've got excellent surface models and points, elevation points for the train tracks and some of the open field, really breaking down in these steep slopes and these forested areas there. So not working well at all. So let's sum it up there. And I don't know, Jon, if we want to maybe turn it back to you for the process here, and
Sure.
or we can answer some questions. I'll just switch you back to presenter mode.
Get my screen here. 1 second.
And I can answer some questions maybe while you're getting set up. So what software are you using to do the point clouds? I think we answered that. Agisoft for Airshark, and we use a customized version of Pix4D here at UVM. Heliports and hospitals, 5-mile restrictions. I have not heard, Jon, of you about 5-mile restrictions around heliports or hospitals?
Yeah, so basically anything published in the airport facility directory from the FAA is what's game out there for the standoff distances from airports and heliports. If it's not published, I believe you're allowed to be closer to heliports because there's a ton of heliports out there.
Yeah, and I haven't had any regulations around hospitals. I mean, if you're flying over a hospital, you probably want to get permission, but I mean, in our case, we're flying a 1.6-pound styrofoam wing. If that crashes into the roof of the hospital, the only thing that's going to be hurt is the styrofoam. Can we contract out flights at night using the IR sensors? If you're the U.S. military in Iraq, yes. For everyone else, I have not heard of the FAA approving any night operations at this point of time. Similar question for the next one. So line of sight only, no coverage acquisition of tens of miles. So if you're talking about 100 miles of data that you need to be acquired, the types of UAS John and I are talking about are not your solution. That's a helicopter or a manned flight. I mean, you could get something like a Predator to do that. You know, we do leapfrog operations where we do a section of a stream, leapfrog up to the next section. But once again, if you're talking about hundreds of miles, you're talking military-grade UAS with advanced over-the-horizon communication systems, not the systems that we're using right now. Other questions about licensed pilots? Yes. Operate with a licensed pilot, template agreement for hiring a UAV 333 company. I'm sorry, we don't, but there's no sort of template agreement. I don't know, maybe John will volunteer you up if you guys have one. And then the other question was conflicting information about delivered from FAA and other sources. Is a farmer flying his fields as a hobbyist, or does he need a 333? So when I've asked this question to the FAA, if he is operating in a capacity of he's going to use that information to make decisions about his farm, that farmer is their commercial. If he is flying his fields with his grandson, who he just bought a new drone for Christmas, that's recreational, and that's how the difference was described to me. I'll turn it back to you, John.
All right, Jarlath, thanks. So I'm just going to go through the process of planning and contracting a mission just to amplify how simple it really is. Normally, there is some sort of initial plan and review between the customer and the service provider. That might be a couple of emails and a phone call, like Jarlath was saying, to make sure that the correct area and expectations are clear early on in the process. That may change over time, but it's important to set those expectations. The quote will obviously be emailed to the customer. The mission planning is an important element, and it's not just planning the flight itself. That's one component, but authorizations and for having an area to launch and retrieve the drone is critical. Also, if there's other authorizations where you may be closer to other people that are not part of the mission, so you may need to put up some signage, and there's a few details like that that are important for denser areas, for instance. We have to notify the FAA of all flights and a few other hurdles administratively. The flight operations component of the process might be the quickest and shortest component of everything. I mean, sometimes it's 2 or 4 hours on a site, which is very common for whether it's a 1-acre site or a 200-acre site. Usually it's a half a day. A full day is unusual for the same site. So the operations component is pretty quick, and the pilot and visual observer are necessary for the operations. Oftentimes, the visual observer is deflecting questions and entertaining the various parties that are there, including the dogs that are running loose trying to attack the drone. So the observer actually is observing the unmanned system and actually helping take away the stress of whoever's operating the unmanned system, because it is energy intensive and draining. Post-processing might be the longest part of any operation. It could be a couple of hours to do some post-processing for a simple ortho photo or a 2D model, or for a complex point cloud data set, it could be a couple of days. Typically, turnarounds are overnight. You're spinning up several servers to run these large data sets using photogrammetry packages, so it's usually overnight. Finally, how do you deliver the data to the customer? Do you have an NDA where you have to hand deliver hard copy data, or can you share it via the cloud? So there's some disclosures that customers often have, and most service providers can handle whatever request comes with data delivery, and also what kind of data. Did it meet the expectations, or does another mission have to be done? So open it up to Q&A again. There's a few other questions coming in. Before we get to final Q&A, I just wanted to list out some resources if I can. Obviously, the FAA. You know, once you get talking to FAA, there's some different folks out there between the Flight Standards Office, the local airports. You know, I think in case of Vermont, we have Burlington, which is Class C airspace. So there's actually employees up there working in that area, and then there's the Unmanned Systems office, so faa.gov/UAS is a great resource. I really like AirMap as a resource for customers that are planning out projects and aren't really sure if that medical helipad is too close for comfort or whatnot. It's a really easy interface. It is a startup company, so it's not federally mandated website, but it's a good resource to sort of do some preliminary scouting around of sites, and it will show you areas to be concerned about. Here's the contact information for Jarlath and his team at UVM, and the phone number 656-3324, as well as our company, Airshark. Feel free to drop an email or call anytime. We are more than happy to entertain questions if stuff comes up. And Leslie, thanks again for putting this on today with VCGI. Yeah, at this point, I think we can open it up for other questions that come in.
Yeah, John, so we got a few here. So one question was about FPV controllers. So FPV, we're talking about first-person viewing. So I think, you know, John, you got Ian who works for you, is probably one of the, probably the best FPV controller outside of maybe some 9-year-olds in the States. So the best FPV commercial operator for UAS. In the case of the system that we use, the fixed wing, that's entirely autonomous, although of course Jon at Airshark is doing autonomous operations as well, but for inspection operations you're doing a lot of first-person viewing. Another question was about any manufacturers using high-end IMUs or INS to improve the photogrammetric approach. Well, I showed an example there where we've got a 1.6-pound system with RTK GPS, where we're getting within single-digit centimeter accuracy in some cases through no use of ground control points. Once again, you know, you could put a giant IMU in one of these systems and then suddenly it weighs 60 pounds and you need a gas-powered engine and an airport. So I think there's always these trade-offs, and right now at least I'm of the opinion that the RTK solutions seems to be really the way to go for accuracy. But they do have, you know, these high-tech IMUs and INS systems in them. They're just really tiny, and I think that's where the technology comes from. The price range for various services here, I think, you know, probably, John, it's sort of safe to say in both of our cases, you know, you're looking at, depending on how much time in your area for sort of a day's work, you're probably talking in the $1,000 to $3,000 range for sort of basic services that run from sort of ortho photos, point clouds, and surface models. And then if you need additional processing, then it goes beyond that. And as Jon mentioned, you're looking in both of our cases, because we're either running services in the cloud or local hardware, we can get you sort of next day turnaround. Commercial registration from the FAA coming in mid-2006. I think they probably meant mid-2016. The last I heard, Jon, when I was down in DC was June 2016. We're probably going to hear some commercial registration, but these are all rumors since the FAA will never commit to anything. So do you have any take on that, Jon?
Yeah, we'll see some movement in 2016. I don't know if it will be June. Everything seems to take longer than it should. So for now, it's a status quo in terms of the 333. We'll see what happens.
Great. Let's see. Someone else had a recording available. Yes. So Leslie Pelch and the good folks at VCGI will have that up on their YouTube channel and up on the website. I think we addressed this, but talk about processing on local machines or web services. In our case, we're using high-end desktop workstations, some of these $25,000 ones, and at Airshark, Jon, you're using Amazon web servers. Is that correct?
Correct, yep.
Great. Can you list some of the most established vendors? Well, without sounding like we're bragging, I think probably in Vermont you're talking to them. Probably the best place to go is the FAA Section 333 website, and you can see who's been certified. I would say in all these things, compared to other aerial mapping costs, these are much lower. And one of the best ways to evaluate a contractor is just say, hey, give me some examples of your previous products, and let me have a look at them. And I think that'll give you a very good idea of what they're talking about. John, I think this is a question for you. If you've conducted mapping for site development.
Yeah, a lot of what we look at, whether it's a renewable energy project going in the ground or a construction project, they're all, at the end of the day, construction projects. So we will do, we're not quite doing the BIM mapping, the building information management, but we're providing real-time ortho imagery to document before and after imagery of construction projects, and we can overlay as-built drawings on those if that answers the question. The other question was, has Airshark conducted end product contracting to provide the just post-process data based on a customer's data need? I.e., does the customer want you to fly the UAS, they also want a particular data set at a specified resolution and spectrum, and they ask for it at a specified price? I'd say partially yes. Certainly, a lot of these customers are figuring out that they have budgets for this right now, but we haven't had too many open-ended. We try to get the customer to come in pretty narrowly with a specific guideline, but we're open to new ideas all the time. I'm not sure if that answered the question or if I understood it. The other one was how strong is the signal from the host unit to the unit? How far could you fly them? Is it more for localized data or county, etc.? These signals can be pretty strong and certainly amplified. The issue today is really line of sight there's a reason for line of sight operation and its safety. There's low-flying helicopters all the time, even in rural Vermont, flying for power lines and medical reasons. But you could certainly fly further autonomously or semi-autonomously without, as it is today.
Yeah, in our case, for our fixed-wing systems, we're looking at 3 kilometers is the max range before we lose the signal. Our system will fly beyond line of sight, both in terms of line of sight for the laptop receiving the signal and our visual line of sight, but FAA regulations don't allow that.
What is the best software for mapping features such as curbing edge of pavements? Jarlath and his team are using quite a bit of Pix4D. We're using Agisoft Photoscan, and they're both excellent photogrammetric packages for doing that. There's a few other ones out there that are aimed at bigger data sets. I don't know if you have anything to add, Jarlath.
Yeah, so I think at the basic level, you'll get products that'll work with any GIS or CAD software, right? You'll have orthophotos and surface models. On the other side, you're going to get some point clouds, and those point clouds would be very large. I use QuickTrain Modeler for that because it's the best software for working rapidly with point clouds, but you can also bring these point clouds into things like ArcGIS and MicroStation.
The specified price would basically demand UAS because that is the only way you could get that data at that price point. I think that was an add-on to another question earlier. Brian, feel free to reach out directly.
Yeah, and I'm wondering there. So I think this probably gets John into where we see UAS going, and I think UAS is going to be sort of very similar to surveying, right? Like you probably are not going to hire a surveyor from Ohio to come and do your UAS work for you in Vermont, for instance. And so, but that wasn't true for aerial imagery, right? When we do the state orthophoto contract for Vermont, those companies may come from all sorts of locations. So I think you're going to be pulling from a localized area, and you're talking about these projects for which it is cost prohibitive to do either traditional manned aerial imagery, or the satellites are not giving you the resolution or the cloud cover issues associated with them.
Here's a good one, Jarlath. Have you been sued yet?
Yeah.
Any pushback to your operation?
Can we make a Fifth Amendment on this?
We get sued all the time. No, fortunately not. It's been really really eye-opening and beneficial to be out there in rural New England mostly for our operations. We have worked in the Boston area outside of Class B, but folks are very proactive and helpful all the way up to the FAA. Just to, it takes time to get through the hurdles, but we've had some interesting questions and projects that we have turned down, but in general, it's all, I won't say it's all positive, but very positive.
Yeah, I'd echo that on our end. We've had a really good reception here in Vermont, and I think it has a lot to do with the attitude in the Green Mountain State, and we're really seeing how beneficial this technology can be for Vermonters in helping out particularly our small companies that may need Airshark's inspection services, or our towns that we've worked with on disaster mitigation and emergency response.
How about over the ocean where there's no power lines or other obstructions, still line of sight only? I'm not too familiar with the international waters, if it's 12 miles offshore or whatnot, but there are dedicated unmanned airspace blocks that I'm aware of, and the FAA test site over on Cape Cod, for instance, there's an area, and there's a lot of military training zones out there scattered about that go on and off. So that 3D space will change over time, hourly or daily too, so it makes it difficult to just say this is an area. So, but there are some blocks, I believe, between Martha's Vineyard and Falmouth, if I'm not mistaken, that's a dedicated unmanned site through that test center. What do you think about maps made? What do you think about Maps Made Easy service? I don't know the answer there.
Yeah, so John, that's an online service. I think they say that you collect the imagery and then they process it for you online. And I think John will back me up on this. I think when you try to divorce the acquisition from the processing, so you sort of make it seem like, oh, I can find, Joe down the street with his drone, go fly it, give me the imagery, and then I'll throw it up on this service, and I'll get some really cool ortho photos out. You may succeed some of the time, but you're going to have a lot of failures there. And I think the advantage of going with a professional is when they have done dozens and dozens and dozens of flights, they understand the intricate issues on the ground that cause problems. So someone who's good at it will understand proper flight line planning based on the conditions and terrain in order to ensure that you get good coverage. So there's nothing wrong with these cloud-based services, but I think you just want to make sure that you have someone with the experience using them so that you get the data that you expect out of this.
What has the Vermont legislature's response been? And in addition, I mean, town, municipalities, and other legislatures as well. I try to stay abreast of this as best we can, but in Vermont, the focus has been privacy and specifically the law enforcement use of drones for when there's a need to implement for a warrant situation or whatnot. So I think the idea there is to make sure law enforcement is transparent and has a warrant to use these. And the legislature's been open because they see the practical elements and the growth of businesses. I mean, there's an ecosystem of unmanned systems here in Vermont already, people making parts, flying, and doing research and development. So I think, Jarlath, you had a good conversation today as well. I think it's mostly positive.
Yeah, I think it is, and the real risk that is out there is that you will have a patchwork of regulations that'll change from one town to the another, and that's especially burdensome if you're a company like Airshark and you're trying to do a solar panel inspection and suddenly there's some new rules you hadn't heard of, or you're like us and you're maybe participating in emergency response. Those regulations may not stand up in court because the FAA governs airspace, but still it's problematic, and I think we're lucky here in Vermont we haven't seen the need to sort of over-regulate, because the FAA is already regulating this pretty stringently, and really impose those hurdles that would either crush business like Airshark or innovation.
I think we're wrapping up towards 4 o'clock, so I don't want to keep people. Like, this has been helpful, hopefully, for others. Feel free to reach out to Jarlath or myself, and we'll have this posted, like Leslie said, later in the week or early next week on the VCGI website as well.
Thank you. Thank you to both of you. And I will indeed get this posted as soon as possible. Thanks to everybody for sticking with us and getting a lot of great information. Thank you, guys.